shifting gears. So in the next 20 minutes or so, we'll share our insights on how to make machine learning really usable. Before I get into that, a quick introduction to the Introspect platform itself. Introspect is Aruba's security analytics platform, and the purpose of this solution is to address two key challenges. The first being, how do we detect and automate the detection of risky behaviors and attacks on the inside of the enterprise? And the second is to reduce drastically the time between alerts and the remediation of those alerts. And the way we do this is through a combination of a big data platform and machine learning technologies. The heart of the value proposition of Introspect is to create these security dossiers. These are profiles for hundreds of thousands of entities, an entity being a user, a device, or a network, so that now you can look at the risk posture for every one of these entities, look at the profile of the risk over time, and also examine the underlying alerts, both generated by Aruba itself and by third parties, for why the risk score is trending the way it is. You can also look into the behaviors in terms of the history of authentication data, the web behavior, so on and so forth. Now to the main topic for this session, going beyond the hype. When we had our technical advisory board here at Aruba a few weeks ago, we had CIOs representing some of the largest organizations in the world, and one common theme that emerged is, what they said is, these days when they hear vendors talk about machine learning, they cringe. So why is that? The science of machine learning is solid, defensible, and utterly useful. The challenges come when you try to apply the science to solving practical problems. And so let's look at what's unique about security and what we do at Aruba to solve this problem. So what I'm showing here is how problems and behaviors get more complex when you add more dimensions to it. When you go from the left to the right, you can see that on the left, if I asked you to estimate the color of the missing square, that's a relatively simple task because it's linear. And with linear general problems, human intuition works pretty well. As you progress to the right, you can see that as I add more dimensions, especially when data is sparse, it becomes increasingly challenging to detect patterns and predict outcome. And so to solve this problem, and this problem exists in the security domain as well, because behavior of humans and devices has many, many dimensions. So we use a couple of different techniques in machine learning. I'll start off describing each one in brief before we get to how we make it easy to consume the results of these techniques. So starting with the left, the simplest or most straightforward method when available is supervised machine learning. So even though you have thousands of dimensions in an n-dimensional hypercube, if you will, for a particular use case, if you can identify the handful of features that completely describe that use case, and if you're able to get enough samples in the wild for both good and bad behavior, supervised machine learning works best with the most high fidelity results. And so we deploy that whenever we get a chance to do that. As an example, DNS DGA, or perhaps finding a ransomware attack, because that's predictable. You can run it in a lab, you can get good samples, bad samples, tell the difference between the two. For example, with DNS DGA, we use features like trigrams, the TLD domain itself, length of the domain, the characters being used, etc. The next technique we used is unsupervised machine learning, where you don't have labels for the data you have, except that you can now understand the structure underlying the data. So as an example, a use case we solve using that is Dns Tunneling. This is an example where an attacker might use the text records in DNS queries to communicate command and control to the botnets. And again, here we first build clusters of these text records based on the nature of the text records, how they are encoded. Our security experts go in, examine these clusters, assign the labels, and after that, it is ready to be deployed in the field. The final technique is that of anomaly detection. Now, This, in comparison to the other two techniques, is not as high fidelity in all cases, simply because not everything that's an anomaly is necessarily suspicious or malicious. However, there are many methods we will talk about in the next 20 minutes that allows us to now combine these simple first-order anomalies and build higher fidelity second-order alerts. So without further ado, let's jump into the demo, and we'll look at how we make it easy to consume the results of machine learning. So as we are getting set up here, let's, I know we are limited time in this last session, so we'll focus on the most important things. There are a few different techniques we'd like to show you in the demo now. The first thing is whenever a machine learning model fires in the system, it annotates the alerts generated using metrics like severity and confidence. We let the user go in and modify the use case, because these are canned use cases that we have created for you. And if you want to slightly adjust them to reflect your own business logic so that you can suppress alerts that you don't care about, we allow you to go and modify the use case so that the results align with what you expect. We don't abandon traditional rules wholesale, because now what you can do is build these nuggets of useful insights using machine learning, but still use human intuition in how you combine them. So as an example, if you want to detect anomalous download of data from an internal finance server, that's a machine learning problem. If you now want to detect anomalous emails going out with large attachments to external recipients, that's a machine learning problem. But the ability to sequence these two to say this happens after that, that's human intuition. And so why not use a rule there? So one of the innovations in the platform is this notion of chained alerts, where you can now use temporal operators to sequence events in time. So now you can say, look for all instances of event A occurring before event B, but after event C, with one of D or E occurring in the middle. And so these are complex relationships in time, which are not normally found in systems like this. And the only reason we are able to do something like this is because this is now really a big data platform where for every entity in the environment, we can look for these temporal patterns.
So do you have a community workspace where people can share their models or download other sample models?
No, we don't have a workspace to download models, but we are very responsive to our customers when they are looking for tweaks to our models. Mm-hmm. One of the things we do is you can simply clone one of the use cases that we provide, and by simply changing configurations, you can create your own use cases.
Sure.
So a good example of that would be, say for a peer-based anomaly detection, which is looking for anomalies within a peer group. If I created a model for you saying, look for anomalies within a certain department, and so instead of department, if you wanted to say, for people reporting to the same manager or people working in the same physical location, that's a change you can make yourself to the model that we ship.
Are these models trained locally on a piece of hardware that's in your data center, or are they trained like on SageMaker and AWS or similar?
So the supervised models are trained at headquarters before they're deployed. All the anomaly detection models are trained on location.
Okay.
So we build baselines for both historical behavior and peer-based behavior, and so that sets up what's normal and expected. And when we see deviations from that behavior, we raise alerts.
Are they TensorFlow models?
These are not TensorFlow models the way we use them today. These are largely Spark ML and models like that, scikit-learn models and ML Spark models. But TensorFlow by itself is also being looked at for some of our newer algorithms and newer use cases, but currently it's not part of the product.
Are you able to backload data? Like if you have like 6 months of syslog data, are you able to backload that into a model to get a baseline of what your user should be doing or have done in the past?
We do that when we train models at headquarters. We don't do that on site.
Okay.
Sorry, question. How much time did you get from the baseline to create a baseline of your network?
So that's configurable. By default, what we want to do is for historical baselines, we look for at least 14 data points in a 30-day window. And those numbers are chosen kind of very thoughtfully. And so anytime we see that, that's the minimum set we need to build a model. But for certain behaviors, if you think you need more training time, that's configurable. And for peer-based detection, all we need is 1 day's worth of data. So given 1 day's worth of data for a peer group, we can start looking for anomalies.
Nice.
Okay, so an average is 1 day or more in an average installation of this solution?
In the average installation, people rarely change our 2-week historical time training window, and 1 day is also the same.
Okay, thank you.
So let's give you a demo of the chained alerts. Now, the other example we want to show you is something we just introduced in our release this year called alert clustering. Now, we talked about classification, and people talk a lot about classification and clustering, but here we're using a technique that's very rarely used by the industry. It's called frequent pattern mining. It's one of the popular techniques in data mining. And so what we do is when we look across all the alerts for a particular use case, we cluster these alerts based on common context. And by context, here's an example. If I see anomalous upload of data into Dropbox, the context could be, is the application the same? Is it by the same user? Is it from the same IP address? Is it from the same location? And so now, rather than chasing down each and every alert for this use case, you can investigate an entire category or a cluster in a single go, and that significantly improves the efficiency of your SOC. To give you an analogy for where you see this kind of logic being used, when you shop at Amazon, you see things like people who bought this also bought these other products. And so that's because behind the scenes, they are comparing the purchase patterns across multiple users. We are essentially doing the same across alerts, where we're looking for common context underlying those alerts, grouping them to make it easy for you to investigate. So let's look at the demo for these two features.
Okay. So what I'm showing you here is basically the alerts page of our UI. So these are the alerts that have been triggered as a result of all the machine learning models that are running on our platform. The example I'll show you here is basically this first alert here, the large data upload to external. And this is focused on IoT devices. And this is an example of an anomaly detection based alert. And for this particular example, it's also based on peer group. And so Introspect actually gets data from ClearPass to get authentication data and device context data. So we're able to understand when a camera gets online, we can actually group that into a device category called network camera. So you can see that information in the summary of this alert. This particular camera actually uploaded, so this is the anomaly. It uploaded 4 to 5 gigabytes worth of data on this particular day. Compared to a peer baseline, the peer group is now the network camera, so all the cameras that are in the environment, which on average have been uploading on the average about 50 megabytes per day, right? So this is a particular anomaly. Now, as Viswesh mentioned, we give this Introspect tool is also a powerful platform for analysts to fine-tune these alerts and also provide some sort of business context. So let's say an analyst says, okay, I see this camera, it may be doing something suspicious, but maybe not, right? Maybe it's supposed to be doing that type of upload. So if I want to modify this use case, I would go under Actions, and I would select Modify Use Case. This is the dialog box that we provide, so that you can actually now provide conditions to exclude certain behaviors to prevent this alert from firing. So if I like, for example, if I like to add a condition, I can just click on condition here. For this particular use case, I can exclude behaviors based on application, destination country, or source and destination IP. So if I wanted to say, I want to exclude data that's going from this camera to a destination country, here we show United States because that's the only data traffic that we've seen so far. So we say this is not a suspicious thing, this is something that's okay to happen. I can exclude this type of behavior, any traffic going to destination country, United States, and I would just submit that as a modification of the use case. So that's an example of what we call modify use case to exclude certain behaviors. The other thing we can do is we can actually also mark a use case. An analyst can come in and mark this use case as, if it is suspicious behavior, you could say, yes, I mark this as a true positive. Or if it's not, I can mark it as an exception. And so that will prevent this alert from firing again for this particular camera. The other concept that, the other concept that Viswesh mentioned is the concept of intelligent alert clustering. So from a security analyst point of view, when they look at an alerts dashboard, a lot of times platforms will provide hundreds of alerts, right? Hundreds of individual first order alerts. And the concept of alert fatigue comes in when they don't know exactly what to prioritize on and which alerts to investigate. So this intelligent alert clustering it provides this SOC efficiency to be able to investigate and fine-tune alerts in a cluster. So what I do here is basically go under to our clusters dashboard, and this is where that frequent pattern mining is actually running on the alerts themselves. So what we see here is we've actually clustered that example that I showed you, large data upload to external. There are actually 12 instances of that alert that happened over the past period of time. And based on specific characteristics or attributes associated with that alert, we can cluster them into this particular group. So the particular attributes that you see that we were able to detect automatically by that frequent pattern mining algorithm is basically app ID, HTTP, it's a camera, username camera room 1, and then this destination IP address. And so now I've actually have 12 alerts grouped into a cluster, and now I can work on that group as a whole. So the same type of modification of use case, I can actually do that for the whole alert cluster.
Now, but this is supporting anomaly detection and identifying problems there. Is there any support for anomaly response, active quarantine, TCP resets, so on and so forth?
Sure. So we do have integration with Aruba ClearPass. So one of the things we do is we continuously exchange information between Introspect and ClearPass, where we send them the risk scores when they change. We send the alert information when they fire. And so now what ClearPass can do, and this is supported both in a manual fashion as well as in a automated fashion, ClearPass can force the devices to re-authenticate, and upon the re-authentication, apply the appropriate policy no matter what they are, with the same existing policy framework that you have in the policy manager in ClearPass today. And so you can take an action to quarantine the user, and then after remediation, put them back in the system.
Thank you.
I can show that real quickly. For every user or device, we build an Entity 360 profile. And you see here the series of alerts that actually have triggered specifically for this user. And you see a risk score that's associated with that user that gets updated over time and increases with every alert that comes in. In order to do that action to ClearPass, let's say you've suspected this as very suspicious behavior, you want to quarantine this user, we can actually initiate that from Introspect. So we have this quarantine function here. This is a manual type action where we can quarantine based on device. So whatever device is associated with that user, we can actually quarantine it here. It will send an API call to ClearPass to do that quarantine enforcement.
Okay. So we just have a few minutes to wrap. We couldn't get to many other parts of the demo that we had planned to show you. But suffice to say that we focused today largely on how to make it easy to consume the results of machine learning. There's a lot other more features in the platform by itself. It gives you retention of data, the ability to search, facet, and visualize that data. It helps you to create your own use cases. So there are many more features, rich investigation workflows for alerts, many more features in the product itself. But in this session, we were focusing largely on how to consume the results of ML. And coming back to the going beyond the hype, so ML is important not only to generate these important insights, but a product only sort of becomes useful when the end user is able to interpret and understand those alerts for why they fired. And so in this product, we take both of these tasks seriously. Thank you.
Could a use case for this be maybe an internal web server that's hosts a portal for customers to access? So you'd be tracking and storing UBA and geolocation data through this system?
We could, but this product is largely focused on internal users where we know their identity. So in that example, when users access that web server, those are sort of identities we don't know. So that's not the traditional or a good fit for this, but this is more for internal users.
And where can we get our NFR copies of this?
So coming
Not
soon.
laughing.
Coming.
So can you describe, is this a hardware device we'd rack up, or could it be a software license module on an Aruba chassis switch?
Right. So in the roadmap for this platform, the data collection piece of it will natively start moving more into the Aruba infrastructure itself. Right now, we sell an appliance for the data collection. It can also be a VM. And the analyzer, which actually does all the machine learning, can be a rack of servers on-premise or run in AWS.
And it's
so we
based-
have customers doing both.
This is based on like a span or a tap or something like that?
Absolutely. We also take logs that are already in your SIM. So we are data agnostic in this platform.
Can you
Are you
feed it
taking
PCAPs?
client logs like from Jamf or?
We take logs like firewall logs, proxy logs, email gateway logs, things like that.
And can you feed it PCAPs?
We don't feed PCAPs in, but if you give us PCAPs, our internal team definitely uses them in refining our algorithm.
Can we take a PCAP out?
NetFlow, JFlow.
We have a deep packet inspection engine, which extracts more than 2,000 odd fields for every packet. And our experience has shown that that is more than sufficient for what people need.
But for compliance, and like if you're in a breach situation, you might want to hand off a PCAP to a
Sure.
DFIR team or something.
Okay. Good point.
Could this work with like Splunk, where Splunk can send the information to it? Because I know it can send out. Would that work?
Yeah, so we do have bidirectional integration with many SIMs.
Okay.
So where the logs residing in a SIM feed the platform, and the alerts are fed back into the SIM when there are many departments that use the SIM as their primary interface. So they can access and launch this in the context of a particular IP address. So say you're working in Splunk and you're interested in debugging a particular user or IP, you can launch this product in context so that it will show you the 360 profile for that user.